and welcome. Today I thought we were going to talk a little bit more about different kinds of interest rates, and we're going to focus on real and nominal interest rates today. So in this video we will discuss the concepts of purchasing power. We're going to talk about the difference between real and nominal interest rates, and we're also going to look a little bit about taxes and inflation, how that might affect our investment decisions. So to give a short introduction, we could take an example and assume that an employee received a raise of the salary of 9% in 1990. And that seems like a rather large increase in the salary, so probably that employee could purchase more that year, right? Well, the thing is, in 1990, the increases in the general price level was actually 10.5%. So although we had an increase in salary of 9%, everything cost in general 10.5% more. So, okay, you have more money, but everything is even more expensive. So did you actually get a gain, or was it perhaps just an increase in the number of money in the economy? So as a contrary example then, in 2012, we could assume that the same employee or some other received a raise of the salary of 1.1%, which seems to be a very low number. And you might think that such a small increase could not enable that employee to have more consumption. But the increase in prices this year was only 0.9%. So although there was a small increase of only 1.1% in the salary, the price increase was even less. So your money increased by a little and prices increased even less. So in fact, you actually have more purchasing power this year. Okay, so we call this general price increase for inflation. And we need to account for inflation to know if we can purchase more or less. So just saying that the money that we have increased by, for example, 5%, it's not sufficient to say, well, now I can purchase a better car or more cars. I actually need to know how much the price of cars increase in order to, well, separate between, do I have more money now or do I have more purchasing power now than I did before? And purchasing power then, it's a term which reflects how much goods you can afford to buy. So if I have 1,000 kronor, what can I buy with it? I mean, can I get only one banana? That's not so much, but maybe I can get a car. Well, then suddenly 1,000 kronor is very much. So you always need to put the amount of money in relationship to how much does things cost. And that's why we use this in term then purchasing power. So that reflects how much goods can I buy with the money I have. So, for example, I like milk. And then you could ask yourself, what is the cost of milk? And you can look at this over many years. So here we have a graph where we can see that the price of milk in the early 1950s was very, very low. So around here, okay, maybe a red pen is not the best one now. Okay, so here in the beginning of the 1950s, milk was extremely cheap. It only cost a few öre, as it's called in Swedish. But over the years, we can see that it's been a price increase. So here in 2005, 1 liter of milk costs approximately 7 crowns. So obviously, it would seem milk must be much more expensive for people today than it was in the beginning of the 50s, right? Because milk costs 7 crowns now compared to only a few öre many years ago. But that's when we do not account for inflation, because the general price level has increased, and as it does, so did people's salary. So you can do something which says that you make it into comparable terms. So we use the 2006 year's price to see how much has milk actually increased or changed. And when you look at it in this way, you can see that in the beginning of the 50s, milk cost approximately a little bit more than 5 kronor in the value of 2006 year's prices. And today it costs a little bit more than 7 crowns. So actually, the price of milk has increased slightly over the years, but not by far as much as it appeared in the first picture. And we can also see that the price has gone up sometimes and down sometimes. So the price fluctuates a little bit in purchasing power, but not at all as much as the actual cost. So here it says that you actually had to pay 1 krona in 1965, but compared to how much 1 krona was worth then, it corresponds to more than 8 kronor in 2006 year's prices. So we have again some terminology for this. What you actually pay for a good, like the number of kronor you have to put up, that's called a nominal value. So if 1 glass of milk costs 10 krona today, then the nominal value is 10 because I actually have to pay 10 krona. If the price then increased to 15 krona next year, well, then the nominal value again would be 15. But maybe everything has increased by 50%. And then you have something called the real value. So the real value is when you adjust for inflation. And the reason you do that is, as always in finance, we want comparable terms. So we don't want to know that a glass of milk cost 15 krona instead of 10. We actually want to know how much has it increased above inflation. So a value that is adjusted for inflation is then called a real value. Okay, so this is very important. We need to distinguish between nominal values and real values. The nominal values are what we actually pay, and the real value is what it's worth compared to some year's price level. Okay, so let's take an example and try to find out if this is nominal or real value we're talking about. If you deposit 100,000 SEK in a bank account and it pays 10% interest rate, and you withdraw your money 1 year later, how much money do you have on the account when you withdraw it? Okay, so we know how to do this. We take the money that we put in, 100,000, and we multiply it by 1 plus the interest rate, 10%. And we see that after 1 year, we have 110,000 SEK in the account. And we withdraw it, and now we have 110,000 money in our hands. Okay, so the question could then be, is this 110,000, is it a real value or is it a nominal value? Well, it's the number of units, number of kronor we have in our hand, and that therefore it's a nominal value. We can't tell here if we can buy more with this than we could with the old 100,000, so therefore it's not a real value. Okay, we can take another example then. If you wish to travel around the world in 3 years' time, and you know that today it would cost 150,000 kronor. Okay, so we know that the cost today, if we would do it today, it would be 150,000. But we want to do this in 3 years' time. And you believe that the price of this travel then, will increase with inflation, so it will increase by 2% per year. Okay, so we know that the price of this trip will increase by 2% annually. And then we also know that the bank can pay us 3% interest. The question then is, how much money do I need to deposit today? So we know how much the price will increase, we know how much interest we will get, and therefore we can find out how much we need to deposit today. So how do we do that? Well, we do it as we always do, okay? We know the price today, it's 150,000, and we also know that the inflation will be 2% per year. So how much do we have to actually pay in 3 years' time? Well, we take the 150,000, we take it times 1 plus the increase in the price, which is then the inflation, and we take this to the power of 3. Okay, so what is this then? Let's see. Well, this is 159,181.2 kronor. So this is what we actually have to pay in 3 years' time. All right, how much do we need to deposit then? Well, we said that we could get an interest rate of 3% in the bank. So we can use the present value calculation, because this value here is how much we need in the future. So it's a future value. So remember, the present value was then the future value, or we called it C, divided by 1 plus the interest rate to the power of n. And here n was the number of years in the bank in this case. So today, in the present value, we need a total of 159,181.2. So this is what we need in 3 years' time. And we divide it by 1 plus the interest rate, 3% in the bank, to the power of the number of years. Okay? If we enter this into our calculators, we find that this is equal to 145,673 SEK, if I ignore all the decimals. Okay, so in order to buy a trip, which in 3 years' time will cost, well, it cost 150,000 today, but the price will increase by 2% over the years. But since the interest rate in the bank is even higher, it's 3%, it means that we can deposit less than today's price and still be able to afford this trip in the future. All right, so here we had an interest rate higher than the inflation. It meant that we need to deposit less than today's price. But you can do this also in a different way. So now we used a nominal interest rate because we looked at how much does our money grow in the bank. Our money grows by 3% per year. Okay, then you do it like this. You can also solve this exercise in a different way. Okay, so we're going to use a real interest rate. What does that mean then? Well, we want to know how much does our purchasing power increase every year. Okay, so when you do this, you want to look at how much will the trip cost in today's money value. So we knew that the price of this trip was going to increase by inflation every year. Well, that means that the trip will cost a number of kronor, which is comparable to what you can purchase today with 150,000 kronor. So you say that the real value in 3 years' time will be exactly 150,000 kronor. So today it costs 150,000. What you can buy with that amount of money in something else, you will be able to buy exactly the same amount of goods in 3 years' time for the amount of money it will cost to purchase this trip. Why? Because this trip increased by inflation, which is the general price increase. Okay, so it might be a little bit confusing in the beginning, but you will probably get used to it as you think about it more and also do some exercises. But the problem is, we know that what the real value is, but we have a nominal interest rate. So this one tells us how much does the money in the bank, how much does it increase by? And that's a nominal increase. It's not the same thing as the increase in our purchasing power. So how do we do it then? Well, we can take a look at it. Okay, so assume that we have 100 kronor in our account today. Actually, let's do it like this. Assume that 1 liter of milk costs 10 kronor. So 1 liter of milk costs 10 kronor today. And in our hands, we have 100 kronor. So what does this mean? Well, it means that we can purchase today. We could purchase 100 divided by 10 equal to 10 liter of milk. Okay, what will happen if we deposit our money for 1 year? Well, if we deposit it for 1 year, then it will increase from 100 to 103 kronor. Okay? How much will 1 liter of milk cost? Well, the milk will increase by inflation, or at least we assume so. So milk will increase in price by 2%. So 1 liter of milk will next year cost 10 kronor and 20 öre. Okay, how many liters of milk can we then purchase next year? Well, we can purchase 103, because that's how many kronor we have, divided by the price of milk, which is 10.2. And here we see that this corresponds to us being able to purchase 0.98. So a little bit more than 10 liters this year. Of course, it might be very hard for us to go to a store and say, I would like 0.098 liters of milk. But the point still stands. We don't need all our money to buy a full 10-liter milk. So if we would buy 10 liters of milk, it would cost 102 kronor, and then we would still have 1 krona left. So our purchasing power has increased. It has increased because the interest rate is higher than inflation. So the money that we have grow in a faster rate than the price level, which means that we will be able to buy more stuff in the future. And how do we then solve the question we actually have here? We know that we need 150,000 in real money in the future, in 3 years' time. We know that the nominal interest rate is 3%. So how can we have a comparable increase in purchasing power? So we could call it a real interest rate. How much does our purchasing power grow by? Okay, so how do we find this? Well, we can do it in pretty much the same way as we did with the milk example. So we would like to know how much does our purchasing power, we can call it RR for now, how much does that grow? Well, we look at how much does our money grow. So we take 1 plus the nominal interest rate. This corresponds to this factor here. And then we divide it by the increase in inflation. So we could add parentheses around both these. And why is this the same thing as we did with milk? Well, when we looked at the milk example, we took 103 divided by 10.2. But 103 is the same thing as 100 times 1 plus R. And the price of milk increased by 10 times 1 plus the inflation rate. So this part that we have here corresponds to how much we could buy before. We could buy 10 liters of milk. This part here corresponds to our increase in purchasing power. So how many more liters can we buy next year compared to what we can do today? So that's why I say that the increase in purchasing power is given by this formula. Okay, it looks like I'm running out a little bit of space to solve the exercise here. But let's see, we can go to green maybe and you will see it anyway. Okay, so we would like to find a real interest rate, and we can do that maybe here. So 1 plus RR is then equal to 1 plus the nominal interest rate of 3% divided by 1 plus the inflation of 2%. If we enter this to our calculator, we find that this part, 1 plus RR, or the real interest rate, is equal to 1.0098 and some other decimals. So if we subtract 1, so we want to remove this guy from the other side, we will find that the real interest rate is 0.0098. And if you notice now, look that this has the same sign, so this 0.098 is the same as the increase in the number of liters of milk that we could buy, which is, it should, because we have the real interest rate here. Or, well, at least according to my equation, that would be the same thing. So it all, like, comes together in the same, it means the same thing. So this means that our purchasing power are increasing by 0.98% every year. Okay, so how much money do we need to deposit today then in order to buy something which corresponds to 150,000 SEK in 3 years' time? Well, we can use the real interest rate and do it as we usually do. So we need today 150,000 divided by 1 plus the increase in our purchasing power, which we had down here. So 0.0098 to the power of 3. And like a strange coincidence, this happens to be equal to 145,673, which is exactly the same number as we found when we worked with nominal interest rate and nominal values. So it doesn't really matter what method we do. If we work with real values and real interest rate, or if we work with nominal values and nominal interest rate, we always come to the same conclusion. Okay, so this is just more or less the same thing as I said before. The nominal interest rate equals 1 plus the real interest rate times 1 plus inflation. When I wrote it in a slightly different way. So if you take this guy and divide it on both sides, so you take this side divided by 1 plus I, we should also do it on the other side. These ones cancel out, and we get an expression which says that 1 plus the real interest rate equals 1 plus the nominal interest rate divided by 1 plus inflation. So that was the same thing I showed in the last slide. This is just a different way of representing the same equation. Okay, now to taxes. It happens to be so that we do not pay tax on the increase in our purchasing power, so not on the real interest rate. We actually pay tax on the nominal interest rate. And also, both for individuals at the moment and also for companies, we have so that the interest expenses are tax deductible. So if I pay interest on my mortgage loan, for example, I can deduct that from tax. And when a company has loans and it pays interest on those, you can deduct that from your profits before you calculate how much tax you need to pay. So it's important to remember we always pay tax on nominal interest rate. So we look at how much interest do we get or how much interest do we pay. And that's where the tax comes in. So you can find the after-tax interest rate simply by taking the nominal rate times 1 minus the tax rate. So if the tax is 30%, it would say that the interest that we have left after paying tax would be the before tax interest rate times 1 minus 0.3, or the nominal interest rate times 0.7. So everything that's left after paying tax goes to us. So that's the after-tax interest rate. Okay, let's take a quick example to compare two investments when you account for tax. So the first investment, you have a 10% nominal interest rate and you have a 10% inflation. So it looks like the interest rate that we gain and the inflation will cancel each other out. In the other case, we have only a 1% interest rate and a 3% inflation. So here it seems obvious that we lose money on this one. I mean, prices increase by more than the interest we get. So the question is then, is investment 2 really worse than investment 1? Well, to answer that question, we need some kind of tax rate. So let's assume that the tax rate is 30%. Okay, then the after-tax rate, which was R times 1 minus the tax rate. In investment 1, we will have 10% times 1 minus the tax rate of 30%. So the after-tax interest rate would be 0.07 or 7%. Okay, so that's the after-tax nominal interest rate. How much does our purchasing power increase by then? Well, we had this formula, 1 plus the real interest rate equals 1 plus the nominal rate divided by 1 plus inflation. And this you can do also with after-tax, it doesn't matter, it's the same formula. So the after-tax real interest rate would then be 1 plus the nominal interest rate after tax, 1 plus 0.07, divided by the inflation, which was then 10%. Okay, and we find that this is we find that 1 plus the real interest rate after tax is 0.972727, and so on. And if we subtract 1 from both sides, we find that the real interest rate after tax is actually negative, and it is minus 0.02727, and so on. So if we put it in percentage, it's minus 2.727%. So we have a negative increase in our purchasing power, or we have a loss in purchasing power of 2.73% roughly for investment 1. For investment 2, we can do the same thing. The after-tax interest rate, you take the before-tax interest rate of 1% times 1 minus the tax of 30%. Means we have left 0.007. And then you find the real interest rate after tax by taking 1 plus the after-tax nominal interest rate divided by the increase in inflation, which in this case was 3%. And here we find that the increase in real interest rate is 0.977, you can say 7, which would give us that the real interest rate after tax, when we subtract 1 from both sides, is equal to minus 0.0223 or 2.23% minus. So actually, as it turns out when you count on it, you have a larger decrease in your purchasing power in the first investment than we do in the second. So despite the fact that we knew already from the beginning that this one was bad and this one had at least the same interest rate as the inflation, because we have so high inflation and because we pay tax on the nominal interest rate, you lose more from the tax here than you do in the other case. And therefore, the combination of inflation and taxes makes the first investment even worse than the second one, although we knew from the beginning that this one was bad. So it's very important to always remember that it's, for our sake, very bad with a high inflation, even if you have high interest rates, because you pay taxes on the nominal interest rate and not the real one. while you don't get a tax deduction for inflation. Okay, let's take one final example before we quit this. So the nominal interest rate is 6% and inflation is 1.4%. If the tax rate is 25%, how much is your purchasing power increasing or decreasing, as we saw in the last example? Okay, so this should be fairly easy after we just done that previous one. We start by computing the nominal interest rate after tax. So we take 6%, the nominal interest rate today, times 1 minus 0.25, which was the tax rate. And this is then equal to 0.045 or 4.5%. So this is the after-tax nominal rate. And then we wanted to know how much our purchasing power was increasing. Well, then we simply need to account for the fact that prices increased by 1.4% per year. And we find that the real interest rate after tax is equal to 1 plus the increase in money, which was 4.5%, divided by 1 plus the inflation of 1.4%. And this is then equal to 1.03057. And if you subtract 1 from both sides, we find that the real interest rate after tax is 3.057%. So our purchasing power increases by 3.057% every year. All right, I was supposed to solve it on this slide. Okay, as a summary then, the real values reflect purchasing power, or how much does it cost in a term which is comparable to different years. And you always need some year as a base. So, for example, in the milk example, I compared everything to prices as if it would be in 2006 year's value. So, how much was 1 krona worth in 2006? Nominal values reflect how much we actually have to pay. So, if the milk cost 11 krona today, then that's the nominal value. If the milk cost 15 krona in 1 year's time, then that's the nominal value. When we do calculations, it's always very important to say that if we use real values, then we have to use the real interest rate. And if we use nominal values, we need to use the nominal interest rate. So we can never take real values and discount it with a nominal interest rate. That will not work. So we need real values if we use the real interest rate. And we need nominal values whenever we use the nominal interest rate. And the normal case is that we're working with nominal values and nominal interest rate because that's simply usually more convenient. But as you saw in the example of the trip, it doesn't really matter. We get the same end result when we discount it back to today. We have the formula here. You've seen it earlier, so I'm not going to talk about it again. And that was it for today. I hope this helps you. Thank you very much.